So in this session, we will start with Python. So in this session, we will cover about Python, what is Python, why programming languages, and like features of Python. We will discuss about Python 2 versus Python 3, where we can use Python, etc. So in this session, we will discuss about the intro part as well as some basics part of Python, like Python variables, data types, etc. Okay, so here first we have what is Python. So basically here as a whole, we can say that Python is a programming language. Okay, it is a type of programming language. So basically, why do we need a language? Okay, so here we have a question. Why do we need a programming language? Like, what is the use of it? So basically, we need programming languages to communicate with the machines. Okay, or we can say that to provide or to give instructions. Okay, so as you know, machine can only understand 0 and 1. So machine can only communicate in 0 and 1, which is known as binaries. Okay, like a combination of binaries. So here machine can only understand zeros and ones. So to communicate with the machines, we need some sort of languages, and that language is known as programming language. And here we have many types of languages. We have Python, we have C, C++, we have Java, we have Golang, we have Ruby, etc. So here we have like a set of programming languages. And why do we need a language? To communicate with the machines, to provide or to give instructions to the machines. That is why we need a languages. Okay, because machine can only understand 0 and 1. And humans cannot learn 0 and 1, or humans cannot understand the set of 0 and 1. That is why we need some sort of languages to communicate with the machines. And then that languages will convert into 0 and 1 so that the machine can understand. Okay, so that is why we need a language, and Python is one of them. Okay, now here we will understand Python with the help of features of Python. So basically here we have like lots of features of Python. So first is it is easy to use and understand. So basically we can say that Python is like easy to use and understand because Python is a high level language. So here we have three types of languages. We have high level, we have low level, and here we have mid level. So here we can type three types of languages. So first we have high level, second we have low level, and third we have mid level. So high level means the languages which is close to human language. Okay, so here we can write close to human language. For example, English. And low level is like which is close to machine language. That is like binaries. Okay, so here we can write binaries. And mid level is like in middle. Okay, so high level is like Python is a high level language because the code or the syntax of Python is in English, or we can say that in human language. And low level is like which is in like binaries. We can say that assembly language is in is a low level language because it is like a combination of binaries, signs, and symbols, which is like hard to understand. Okay, and Python or C++, like these, we have these are the like high level languages. Okay, so here we have three types of languages, which is like high level, low level, and mid level. So Python is like high level languages. That is why Python is like easy to use and easy to understand because it is written in English. Okay, second, Python is open source. Open source means first we can use it for free, right? So it is free to use. Second, we can read and modify the source code of Python. So here we can or read or modify, or we can say contribute to the source code of Python. Okay, so Python is like open source. So here we have three types of applications. We have open source applications or languages. We have freeware applications or softwares, and third we have paid applications. So open source is like we can use it for free. And second, we can modify or we can read the source code of that application. Second, here we have freeware. Freeware is like we can use it for free, but we cannot read or modify the source code of that application. And third, we have paid. Paid is like we have to pay for it. Okay, that is like paid applications. So Python is like free, like it is like open source, which is like we can use it for free. And second, we can modify or we can read the source code of Python. Okay, then here Python is interpreted language. So Python is like a interpreted programming language. So what is the means of interpreted here? So basically, let's take an example. So here we have C or C++ code. So in C or C++, here first we have to code, then we have to compile, then we have to run the code. So here we have three processes. First, we have to code it, whatever you want to code, we are coding. Okay. Then we have to compile it, then we can run it. So it is like the syntax, sorry, the extension of C is .c file, any file name .c or C++. Second, here we have compile. So here we will run a compilation process. Then we are here we have a .exe file. Okay, so this is like this is how we can run our C code or C++. Same as here we have Python code. So in Python, here we code and then we can run it. So there is no compilation process in Python code. So in C or C++, here we code, we compile, and then we can run. So and if there's any error or if you want to fix anything or here we want to make any changes, so first we have to code it again, like we have to make changes, then we can compile it again, and then we have to run it. But in Python, it is like very easy, and we can code and we can directly run it. So there's no compilation process. So here, compilation process is because to convert your language, to convert your code into binaries. That is why we have a compilation process. Okay. And to fix any type of error or to check for any errors. And in Python here, the compilation process is doing by your interpreter. That is a Python interpreter. So the all process of the compilation process is done by this Python interpreter. That is why here we don't have any compilation process. Okay. So here we can say that Python is an interpreted programming language. Then Python is general purpose. So general purpose means we can use Python everywhere. Like we can use Python in every domain. For example, we can use in web development, basically in backend. We can use in application development. We can use in security lines like cyber security for creating malwares or tools. We can use in networking. Okay, and more else we can use in automation. We can use in GUI applications. That is in graphical user interface applications. We can use in AI, in data science. We can use in ML, etc. Okay, so here we have various uses of Python. That is why we can say that Python is our general purpose. Basically, we can use Python in every domain. Okay, so now here a question arises, why here we can use Python everywhere? Okay, why Python is our general purpose? Because Python has vast amount of frameworks, libraries, and packages or modules. So Python has like vast amount of frameworks, libraries, and packages. That is why we can use Python in every domain. So for each and every domain, we have different libraries or different frameworks. For example, for web, we have Django. So basically, we can use Django or Python for backend development in website, like in backend side. Okay, for the application, we can use Flask. For the cybersecurity, we can use multiple libraries. For the automation, we can use Selenium, WebScrapePy. Okay, for the GUI, we can use Kinter. Okay, for the data science, we can use Pandas, NumPy, Matplotlib, etc. Okay, so basically here we have like various uses of Python. So here we can say that Python is like a general purpose, and here we can use Python in every domains. Okay, that is why it is so powerful. So here the next point, it is so powerful. Okay, because here we have multiple uses of Python and it is like easy to use, easy to understand. That is why Python is a very powerful language and it is in demand. Okay, so these are some basic features of Python. Now we can move to Python, types of Python. Basically, here we have Python 2 versus Python 3. Python 2. So there's like a syntax difference in Python 2 versus Python 3. For example, here let's say in Python 2, we write, let me write ahead in Python 2. So here in Python 2, we write print hello world. So in Python 2, we write print without parentheses hello world. And in Python 3, we write print these parentheses, which is known as round brackets or round braces, and this word, whatever you want to print. So here, so this is a syntax difference. Second, we can write in Python 2, we use raw underscore input. In Python 3, we use input for taking input from the user. In Python 2, we use X range. And in Python 3, we use range. Okay. And whereas there are like many libraries and frameworks which we can use with Python 3, but we cannot use with Python 2. Okay. So these are like some basic difference in Python 2 and Python 3. Okay. Now here we have Python history. So Python was invented by Okay, so Python was invented by Guido van Rossum in 1991 at CGI Labs in Netherlands. Okay, so and we can say that the base language for Python is AVC language. Okay, so basically the base language of Python is, we can say that AVC language is like a base language for Python. And the idea of Python was like basically taken from this AVC language. And the name of this Python, like why we have like Python name, because of a famous, or we can say a popular comedy show that is Monty's Flying Circus. Sorry, Monty's Python Flying Circus Show, that is here. Okay, so here that is why we have a name Python as this language. Okay, because of that popular comedy show. So these are like some history points. Now, why do we learn Python? Because Python can be used everywhere. Okay, and Python is in demand. And here we can use Python every domain for the development of different like applications, tools, or websites, or malwares, or viruses. Okay, or models. So here we can use Python in like multiple domains. So we can use Python in first in website development, in application, in cybersecurity, networking, etc. Second, Python is like easy to use and easy to understand. That is why it is like here we can adapt any programming language, and that is Python. Okay, so now here we have a where is Python used? So Python can be used everywhere. Okay, now the softwares of Python. So basically here we will use Python 3.11. Okay, and second we will use a IDE, which is known as Integrated Development Environment. And basically we have like many IDs. We have VS Code, we have Atom, we have PyCharm, we have Jupyter, we have Spider, etc. So here we have like many IDs. We have Anaconda, which is like a set of IDs. Okay, so you can write contain set of IDs. So basically for the sessions, we will use VS Code because it is easy and it is like beginner friendly. We can use it in various manners. Okay, and VS Code has like multiple extensions. So here we can install those extensions and we can use it freely. Okay, without any error. So for the Python installation, you can visit Python website. Okay, so here you can search for Python download. So click on here and install your Python 3.11.2. Okay. So you can install it for Windows, for Linux, for Mac, okay, for any OS. So here we can say that Python is like a cross platform. We can use in every domain and in every like operating system. Even we can use in Android and iOS. Okay. And for the IDE, you can search for VS Code IDE, which is Visual Studio Code. So you can click on here, click on this Windows. So you can install this VS Code for Windows, for Mac, or for Linux. Okay. And for Linux, you can apply, if you want to install in Linux, then you can apply apt-get install Python D. So this is for Debian based systems. For the Linux, for the Red Hat based OS, you can use yum search Python, and here you can use yum install Python. Okay. So this is like the commands which you can apply in Linux as well. Okay. And the installation process is like straightforward. Just click on next and install. And whenever you are installing Python, make sure you are click on that option, add to path. So this is option. So make sure you are adding your Python to your environment variables path, which is very important. Okay. So remember to take this option whenever you are installing Python. Okay. Now, here we have to use some extensions of VS Code. So here we can write VS Code extensions. So here first we have to install Python as an extension inside VS Code. Second, we have to install that code runner. Third, VS Code icons. Okay. Fourth, code formatter. Okay. So we can open that VS Code. Okay. So here, this is like the icon of VS Code. Open it. So the interface of VS Code is like not taken. Okay. Here you can click on any file. You can open any file. You can open new window. You can create new file. You can save any file. Here in the preferences, you can change your theme as well from here, color theme. Okay. So, and here you can click on extensions. So first search for Python. Click on here and click on that Python by Microsoft. Click on install here. After Python, search for VS Code icons. So click on here for VS Code icons. Now search for code runner. Click on here, code runner, and click on install here. Now fourth, click on search for Prettier and click on this code funder. Prettier. Click on install here. So these are some 4 important extensions for VS Code. After installing your all extensions, restart your VS Code. Okay. Okay, so this is how you can install your VS Code and Python. So for confirming that your Python has been installed successfully, you can search for CMD here, and here you can type Python. Okay, enter. So this will show you the Python version you are using. Okay, in my case it is 3.10.5. Okay, and in your case it will be like 3.11.2. So this is your Python version, means Python version. Okay. So this is how you can confirm that your Python has been installed. Or you can use Python IDE, which is like Python IDEal. This one. Python IDEal stands for Integrated Development Learning Environment. So here we have Python IDEal as well. So you can use it for coding as well. It's your choice. So here you have Python IDEal here. So basically we can use it. You can type print hello world. Okay, but in our case we will use VS Code. Okay, now how to create a file? So basically what we can do, we can create a folder here. Okay, right click here. Let's create a folder with name Python underscore files here, and drag your folder over this VS Code icon. Open it. So this will open your VS Code inside that folder inside your VS Code. Okay. Now here you can click on these options. This is for new file. This is for new folder. This is for refreshing your files. Okay, so click on here and name your file. So let's say hello.py. Okay, so the extension of Python is .py. Name of your file and .py. So now let's write a first code. So here you can hide this from here. Okay, so let's zoom in. So here you can type print hello world. Control S for saving it. Make sure you are saving your file whenever you are making your changes. Okay, so here you can see this dot sign, this white dot, which means your file is unsaved now. Okay, so here this dot, white dot means the file is unsaved. So whenever you want to make your changes save, you can press Control plus S to make your changes save. Okay, that is Control S. So whenever you press this dot will disappear. Control S, and here you can see, one second, Control S, and here you can see now dot has been disappeared because of your file has been saved now. So whenever you are seeing this dot here, means your file is unsaved. Okay. So now file is saved. You can click on this run, and this icon, this play icon, is because of that code runner extension. Okay, so here you can click on that button and hello world. So this is printed. So here print is a function. So here we can write about print, that is so basically print is a function which is used to print the output. Okay, so that is print. So this is all about installation process, installation of Python, installation of VS Code, IDE, and installation of extensions. Okay, now we can move forward with the variables. Now first is variables. So here we have variables in Python. So basically what are variables? So here we can write variables are like the container which is used to contain or store your value. That is known as variables. So here we can say variables are like the container which is like storing a value. For example, here we have a container. Let's say this one. So this is my container. Okay. And let's name this container A. So this is my name of my container A. You can name your variable anything. Okay. So this is A is my name of my container. And here we are storing a value. Let's say 1. 1 is a value here. Now you are storing this one value to this container A. And here 1 is contained. This is known as variables. So this container is a variable here. And here 1 is a value, which is like we are storing a value 1 inside this container. Or we can say a box, whatever. Okay. So anyways, so here we can take an example. For example, A equal 1. So 1 is a variable value here. A is a container, which is your variable, and equal sign is known as a assignment operator, which is assigning a one value to your A variable. So here we can write A is a variable, equal sign is a operator here, which is and 1 here is a value. Okay, so A is a variable here, equal is operator here, which is like used to assign your value to your variable A, and 1 is a value here. Which type of value it is? It is basically a number. Basically, we have different forms of number inside Python. We have integers, we have complex, we have float. So that we will discuss soon. So basically, at a whole, Variable are like the container which is like storing a value. That is known as variables. Now here we cannot name anything to my variable. Basically here we have some naming conventions. Okay. So here we can say naming conventions, which is also known as rules of naming a variable. So basically for naming a variable, we have to follow some rules. Okay. That is known as naming conventions. For example, first, spaces are not allowed. But you can use underscore in place of space. Okay. So basically spaces are not allowed. So here you can use underscore in place of spaces. For example, let's say first space name equal John. So first space name. So this is a invalid variable. So but for the valid we can use underscore. First underscore name. So this is a valid variable. Okay, so basically it is a valid variable name. Okay, so basically spaces are not allowed in variable name. Okay, you can use underscore in place of space. Second, so basically we cannot use numbers in starting, but we can use in middle or at last. For example, here we can use numbers in middle or at last. For example, one num equal any number. Okay, so this is an invalid variable. So basically, your first one num is an invalid variable name because it is starting from number one. Okay, sorry, one and num. So here we are using number at starting, which is invalid. So we cannot use number in starting. But here we can use number at last or in middle. For example, num one. Okay, so this is a valid variable name. Or we can use numbers in middle. For example, first one num or any number. Okay, of your choice. And your value here. So here third point, reserved words are not allowed. So here what are reserved words? Or here we can say keywords. So here we can define reserved words. So basically reserved words are not allowed. Okay, for example, print is not and or for example for while etc. So these are not allowed in your Python variables. Okay, because these have like they have like special meaning for the Python interpreter. That is why we cannot use these words as a variable name. Okay. So here we can write reserved words, or we can say that keywords. So these have special meanings for the Python interpreter. So that is why we cannot use these reserved words as a variable name. For example, print equal, let's say any sentence here, or we can say John. So this is a invalid variable name. Okay, but here we can use print underscore one. Okay, that is John. So here print underscore one. So underscore one is not a reserved word. Okay, or it is not a part of that word. So print underscore one, here we can use this. Okay, particularly this print or print is not, and, or, for, while, else, if. So these are some reserved words. Okay, even we have some more reserved words. So we cannot use these words as a variable name. Okay, and this is your valid variable name. Okay, now point number 4. So basically, we can start variable name with uppercase, lowercase, or underscore. For example, first, so F here is uppercase, so here we can start. Small f we can start, and we can start with underscore. So we can start your variable name with uppercase, lowercase, and underscore. Okay, so these are all valid variable names. So now here we have special characters are not allowed. For example, special characters are like these are some special characters. So we cannot use special characters inside your variable name, even anywhere in your variable name. Okay, so for example here, first, or here we can use NAME. Okay, that is John. So here N A is a like at the rate. So here we cannot use special characters as your variable name. Okay, so this is an invalid variable. So now the last point, that is always name your variable according to the values you are assigning. So basically, always name your variable related to your values only. For example, here we can say that, let's say here we are storing someone's age. So age, here let's say A is equal to 18, or age equal 18. So which is valid, or which is like basically both are valid, but which is like more reliable. So basically, this one is more comfortable than this one because here we can know, here we are like here we can easily define that okay, we are storing someone's age. That is like the name of a variable is indicating. Second, A is like a here A is a particularly a variable, 18 is a value. So here we are not sure that what kind of value or what is like the value we are storing. Basically, here we are storing an integer value, but here we are not sure. Okay, like what is the means of this value here? But here in this age, 18, so 18 is our value. Okay, we know this is a number, but here we are assigning inside age variable. So we can easily define that. Okay, so here we are storing someone's age. Okay, that is like you always name your variable which is related to your values. Okay, for example, here B equal John. Or here we can say so B is a variable which is storing a John value. So here we are not sure what is John here. But name is a variable which here we are storing John as a value. So here we are now confirmed that okay, we are storing someone's name here. That is John inside a name variable. Okay, that is why it is important to always name a variable which is related to your value. So these are some points of naming your variables, which is known as naming conventions. So we can apply this inside your VS Code. Okay. So first we can use name equal John. So name is a variable here and John is a value. Now here we can print the value of John, sorry, the value of your name, which is here we can put name here. So this will print John as a value. Okay. Because here we are assigning name as a variable name. So here basically here we are printing the value of this name, which is John. Okay. And here what if we write name this one? And here we can write John. So this will throw an error. Okay, because here we are using special characters. And special characters are not allowed. Okay. Same as if we are using first space name equal let's say John. So here we are using space and spaces are not allowed. So here this will throw an error. So what we can do, we can replace the space with underscore, this one. And here we can print first underscore name. Okay, and we can run this. And here we have John and here we have John. The second value is also John. Okay. So next here we have number. One num equal 10. So one num is a variable which is like invalid. As you can see a red line here, because one num is a one num. It is starting from number. That is why it is invalid. So what we can do, we can write num1 equal to 10. Okay, so num1 equal 10. So num1 is a, now this is a valid variable name and we can print it using num1. And we can remove this. So here you can see 10. So 10 is a value which is inside a variable number 1. Print num1. Okay. So these are some variable rules we have to follow. Otherwise, this Python interpreter will throw an error. So make sure whenever you are applying your variable name, whenever you are assigning any variable name, so make sure you are using the naming conventions. Okay, which is like rules of naming a variable. Otherwise, the Python interpreter will throw an error. Okay. So now here we have data types. So these are variables, which is like a container which is storing a value. Now here what kind of value you are storing, this is known as data type. Okay, so here we can type So basically, the kind of value stored inside any variable is known as data type. For example, here in this variable, this one equal to a. So here we are assigning one value to variable a. So here what kind of value this one is? That is data type. Okay, so here we are like basically like many types of data types. So the kind of value we are storing inside any variable is known as data type. Okay, let's say let's make it more clear. A or here let's say number equal 1. So number is a variable here. Okay. This equal sign is a assignment operator because it is assigning a value to a variable number. One is a value here. So here we can write what kind of value we are storing. Okay, what kind of value we are storing inside any variable is known as data types. Okay, which is like what type of value we are storing inside any variable is known as data type. So in this case, one is a number which is an integer value. Okay. So here we are like many types of data types. So first we have strings. So here we can write combination of characters inside single, double, and triple quotations. Are known as strings. Okay, so basically it is like combination of characters inside single, double, or triple quotations are known as strings. For example, let's say A equal hello world. Okay, so this value hello world, it is inside quotations. This is known as quotations here. Okay, so here we can write this is your quotations. So double quotations, this is single quotation, and this is triple quotations. This is your double quotations, single quotations, and here is your triple quotations. So any set of characters inside these quotations are known as strings. Okay, so whatever inside these quotations, they are always known as strings. Okay, for example, here. So Python is a powerful language. So it is a sentence. It is inside single quotations. Here you can see here it is inside single quotations. So this is known as a string. Or here we can write any set of characters inside, let's say, so this is also a string. So basically in Python, we use double or single quotations. Okay, mostly we use double or single quotations. Okay, so any set of characters inside single, double, or triple quotations are known as strings. Now here we have numbers. So inside numbers, we have three types of form here. First, here we have integers. Second, float. Third, we have complex. So here we have complex numbers. Here we have float numbers. And here we have integer numbers. So integers are like some basic numbers, okay, without any point, any sort of numbers. So these are integers. Any minus number, negative number. Okay. So these are integers. Float is like decimal point number. It's known as float numbers. Okay. So these are like float numbers. Complex, it is like a combination of your real or imaginary number. That is like, let's say 1 plus 2e. So 1 and 2 is like real number, e is like your imaginary number. So it is like your combination of real and imaginary number. Okay, so that is why we have integers, float, and complex. Then we have Boolean. So Boolean here we have. So here in Boolean we have two values, that is true and false. Okay, so in Boolean we have only two values, true and false, which is here we can say Boolean. In short form we can say bool. Okay. For the numbers in the integers we can say int, short form of your integers. And for the float, there's no short form. Okay, float is only float. Same as with complex, no short form. For the strings, we have str. Okay, so these are some keywords which is used to identify the strings, numbers, integers, complex, float, boolean inside your Python. Okay, so boolean here we have two values, true and false, that is 0 and 1. Okay, so whenever we are using any boolean values inside your Python, make sure your T should be in capital and F should be in capital. Okay, then only we can apply any boolean values to your code. Okay, so let's apply this. Let's check the type of values we are storing inside any variable. Okay, so here we can type name. So name is a variable, equal is assignment operator, John is a value. So here we are assigning John value to your variable name. Okay, now here we can check. First we will print name. And here we can run it. So John here is a name. Okay. So name is a John is a variable value, and here we are assigning variable John to your variable name. John is a string here because it is inside quotations. Okay, 1 second. Now second here. Now here we can print the type of value we are storing inside your variable. Okay, that is print type. So type is a function here, and here we can name your variable name. So here we can write type is a function. Okay, so type is another function which is used to display the type of value we are storing inside any variable, which is in case here we are applying a John value. John is a string because it is inside quotations. So these are quotations here, double quotations. So here we are putting John inside a quotation, and here we are storing your John value to your variable name. And here we are printing the name value, that is John. Now here we are printing the type of value we are storing inside name variable, that is string here. Okay, you can see class string because here John is a name. Okay, and what kind of value we are storing inside that name value, main name variable, is known as string because it is inside quotations, or any characters which is inside quotations like double quotations, single quotations, or triple quotations. Those are known as variables only. Okay, so next we can try with single quotations. Okay, for example, here we can try name underscore one. So name underscore one is another variable which is taking apple as a value, which is inside single quotations. Okay, which means it is a string. Okay, now here we can print your name underscore one, value of your name underscore one variable. Second, we can print type of value we are storing inside name underscore one. Okay, so here we can run this. So here you can see apple is a value, and what kind of value apple is a string. Why it is a string? Because it is inside quotations. Okay, so any character, even if it is a number, if it is any like different type of value, whatever is inside quotations, they are all known as strings. Okay, so for example, here, let's say number 10. So 10 is a value for us, right? 10 is a number, 10 is a value. But here we are putting your number inside quotations. That is, you can see double quotations. Now, if we print number and we can print type of value we are storing inside number, we can remove this. And here we can run this. Now here you can see it is a string here because 10 is a number and it is inside your quotations. Basically, it is a number for now, but here we are putting a number inside quotations, that is double quotations. And here we are putting your number or your string inside a num1 variable. So when we check the type of value num1 is storing, that is your string here, because it is string here, because it is inside quotations. Okay, same as we can try with single quotations. So number underscore 2 is a number here, 11 is a number for us. But here it is inside quotations, which is single quotations. So whatever value, whatever character inside single quotations, they are all known as strings. Okay. So when you check the type of value you are storing inside number underscore 2, that is a string. So we can run this, and here you can see, here you can see it is a string. Okay. So this is how we can use strings. Now, same as we can try with integers, float, and complex. Okay. Now, for the integers, integers are like non-decimal numbers. So we can write num1 equal 10. 10 is a string integer here. So when you print your value of num1, same as here we can run print type of value we are running inside num1. So type of value we are storing inside a num1 variable, that is integers, short for int. So 10 is a number because it is a number only. It is an integer value. And which type of number? Basically, it is a integer value, short form of int. Okay, which is like integers. Print your number, that is your value. Second, what kind of value we are storing inside any particular variable, that is class int. Okay. Now, same as we can try with float numbers. For example, num second equal 10.12. Okay. So 10.12 is a float number because it is a decimal number. So you can print num2 as a variable name, and print here we are checking type of value we are storing inside num2. Okay. So 10.12 is a value here. We are storing inside num2. Num2 is a variable here. So print num2. Num2 is our value. Okay. And what kind of value we are storing? That is float. Okay. When we run this, so here we have the answer. Value here, and here we have a float. So which type of data type we are storing? That is float. Okay. Now CMS we can try with your complex number. That is, we can write num3 equal, we can write 1 plus 2j. Print num3, which is your value of your number 3 variable. And here we can print type of value. Here we are storing inside num3. Right. We can remove this line. Now here we can run this. So num3 is a complex number. And what kind of number it is? Complex. Here you can see it. Okay. So type function will print what kind of value we are storing inside any particular variable. Same as we can try with Boolean values. That is a, or we can say bool underscore 1 equal true. Okay, so here we can print type of value we are storing. Here we can print type of bool underscore 1. Okay, so print bool underscore 1. So bool underscore 1 will print your value and print type of value like bool underscore 1 variable is storing, that is Boolean values. Here we can save it, Control S, and we can run it. So here you can see true is our value and class is bool, which is Boolean. Okay, short form Boolean. Same as we can try with false. So here you can write false here, and here we can run. Here you can see false is also a Boolean values. So whenever you are using your true or false, make sure it is in capital letter. F and T should be in capital. What if we write in small? So this will throw an error because these are not Boolean anymore because F in small case. If you run this, we will have a error. That is this one. Okay, did you mean false? So whenever we are using or that true or false, make sure your T or F should be in capital. Okay, so now let's perform some operations with these data types. Okay, so first here we have first underscore name. Here we can write John. We can write last underscore name. So here we can take any surname, that is Sky. Okay, same as we can write print. Now here we can concatenate strings, that is first name or last name together. That is here we can write first name plus last name. Okay, so here we are adding two strings. So here we are adding two strings. Okay. And this process is known as concatenation. Okay, whenever we are adding two strings together, that process is known as concatenation. So here we are adding John and Sky together. And when we run this, we have answer. John Sky without any space. Okay, so here we don't have any space. So even we can add space here. So how we can add it? So here you can use plus sign one more, and here we can use a space here inside quotations. So even if you want to add a space, we have to add inside quotations. Okay. So here we are adding one space here. You can see one space. So when you run this, we have answer Python or one space or Sky. Sorry, John space Sky. Okay, so whenever you want to add space in Python, make sure you are adding inside your quotations. So you can add as many space as you want. And when you run this, you answer John lots of space and sky. But if you want to add space like this, for example, here you are adding space here like this. So this will be not counted by Python. So Python will not count this space because these are without quotations. So whenever you want to add a space, you will use quotations only. Okay. For example, here, let's remove this. Here we can use plus and quotations. So here we can add any number of space. And here you can use single, double, or triple quotations. Okay, so here you can see we can use any number of like spaces, but that should be inside your double quotation or single quotation. Okay, so here we are adding two strings, that is John and Sky. So this process is known as concatenation. Okay, so let's add this as a with this single space. Okay, or here you can use space here. You can add a space here after this quotation. Save it. Now here you can see a space here, one space, or you can add a space here before Sky. So this should add a space. So here you can use the space after John or before Sky, or you can add a space here inside here, one space, that is John Sky. Okay, so this process is known as concatenation. Even you can repeat a single string. For example, if you want to repeat John many times, so here you can write first name into, let's say, 5. So here we are printing 5 times John. So here you can see John 5 times. John first, second, third, fourth, and fifth. So here we can repeat strings with the help of this multiplication sign here. Okay. So you can repeat strings 20 times. Okay, so here you can see we have John 20 times. Okay, so there's a note here. So we cannot add strings and numbers together. So basically here we cannot add the strings as well as numbers together. Okay, for example, here, suppose num1 is 10 here, or here you have a name that is John, or we can say, okay, num1 10 or name John. Here we cannot add name plus num1 here. So this will throw an error because here we are trying to add John as a string here, 10 as a number. So here we cannot add John as a string and number 10 as a number here. Okay, so basically, but here you can make this number as a string, this one. Now this is your string as this is inside your quotations, and any letter, any character which is inside quotations are known as strings. Okay, so here this is your string. So 10 is our string here. So here we can add string together, but here we cannot add strings or numbers together. Okay, for example, here you can say John 10 because John is a string and 10 is a string here. But here we cannot add a number and a string together. Okay. So, but here we can add number together. For example, here we can add num1 equal 10 and num2 equal 11. Print num1 plus num2. So here this process is known as addition, right? Because here we are adding number 1 and number 2 together. So number 1, 10, number 2, 11. So number 1 is a variable, 10 is a value. So here we are assigning 10 value to a variable num1 and num2. And here we are adding num1 and num2 together, which is known as addition. Okay, 21 is the answer because here we are adding two values together. And what if we are making these values as a string? For example, number equal 10 here, num second equal 11 here, and print num1 plus num second. So num1 is a string here, num second is a string here. So answer will be, but these are numbers for us, right? These are numbers for the humans. But for the machines, these are strings because these are inside quotations, double quotations. You can use single, triple, or double, any type of quotation. So here you can check we have 1011, which is 1011. So this process is known as concatenation because here we are adding two strings together, num1 and num2. Because num1 is a variable name. Okay, but value is string here, right? Or if you want to check your value, so here we can put print type of value we are storing inside num1. Same as here we can put type of value we are storing inside num second. So here you can see these are strings. Num1 is a string, but means num1, the value which is storing why num1 is a string, same as num2 is a string. So whenever we are like adding two strings together, which is known as concatenation, and that is 1011. Okay. Because for the Python interpreter, these are strings, not numbers. But when you remove these quotations, now these are numbers. Okay, here you can see these are numbers. And when you run this, we have answer. Integers, which is numbers, and 21 is answer. 10 plus 11. Okay, now, so next we have some more data types. So first, here we have list. Okay, we have tuples, we have dictionaries, we have set, and we have frozen set. So here we have these types of data types. List, tuples, dictionaries, set, and frozen set. So list is like which is inside square brackets. So in these data types, in strings, numbers, and boolean, we are storing one kind of value. For example, name. Name is a variable and John is a value here, right? Name is a variable and John is a value. So in this here, we are storing one type of value that is string. Okay, we are storing one value that is John inside any one variable that is name. And it is like one type of value. So what if we want to store multiple types of value? Okay, like suppose I want to store numbers, integers, float, complex, boolean numbers together in one variable. For that case, we use list, tuples, dictionaries, set or frozen set. Okay, list is like, for example, here we have fruits equal. We can use square brackets for the list. And here we can name some fruits here. So here apple is a element. So these are known as elements. Okay, so here we can write. So apple is an element. So this is first element. Okay, not as per the index number. This is for now, it is a first element. This is second, orange is a second element, and grapes your third element. Okay, so in your list, these are known as elements. Okay, we can call them elements or we can call them values. So apple is a element, orange is a element, and grapes is a element. So these are known as elements. But here we are storing multiple elements or multiple strings inside your fruits. Fruits is your one variable. So it is a first variable or one variable. And inside one variable, we are storing three strings here. As you can see, apple is one string, orange is one string, and grapes is one string, which is separated by this comma here. Okay. So apple is your first element, orange is the first element, or grapes is the second element and third element. So these are known as elements. And which is separated by a comma. So in this list types of data types, we can store any kind of or any type of data types. For example, we can store numbers, we can store integers, we can store booleans, we can store strings together. Even we can store list inside list. Okay, so basically here we can store strings, numbers, integers, float, complex, and more else we can store list inside tuples. Sorry, list inside list. We can store tuple inside list. We can store dictionaries inside list together. So basically, we can store any type of data type inside these list, tuple, dictionary, or set of rows inside. Okay, and here we have this list, which is inside square brackets and separated by this comma here. Okay, this is like the proper way or proper syntax of writing a list. Okay, so here we can store numbers, we can store any type of value, and here we can store any type of boolean values. And here we can store list inside list. Okay, list of any numbers or anything. So here you can see this is your strings, these are strings, these are numbers. So these are integer numbers. This is float number. This is your boolean numbers, and this is a string here. So here you can, sorry, this is a list here. So here we are storing list inside list, right? So this is a list. Here we are storing the list inside list. Or here we can even store tuples inside list, dictionary inside list, set inside list of rows inside. Okay. Same as we can use tuples. So here we can, but for the tuples, we use round brackets or parentheses. Okay. So here we can use parentheses. And here we can write like, we can make a variable here. We can name your tuple anything. Okay. Now here you can see apple is our string, oranges strings, and grapes are string here. 1, 2, 2.3, and 2, these are all strings. Right. So basically here we are storing strings, combination of different data types inside your tuples. Okay. Which is like inside your round brackets, which is known as parentheses. Okay. So this is how we can write tuples. So here we can include list inside tuples, tuples inside tuples, dictionary set inside tuples. Same as dictionaries. But there's like a different way of writing dictionaries. Basically, dictionaries are known as key value pairs. So dictionaries are known as key value pairs, which is like this is your name of a dictionary underscore one. Name here is a value. John here is a name here is a key, and John is a value here. Age is a key, 18 is your value. So which is like combination of key value pairs. Okay. So here name and this John. This is one key value pair. Okay. Which is separated by a comma. And second key value pair is age or 18, which is second key value pair. Okay. So here we can say that name, this one, name and this one. So name is your key here and John is a value. Okay. And here which is separated by comma. Age is our key and 18 is a value. So this is one key value pair and this is second key value pair which is separated by a comma. And your name, your key and your value is separated by this colon here. Okay. So here we can say that this is known as key value pair. And here we can add as many key value pair as we want. Okay. So this is dictionaries. Now same as set. Set are inside curly braces. Okay. So these are here we can store any type of data type here. Okay. Same as with these, like we can store strings here, we can store numbers, we can store float numbers, boolean values, we can store list inside set, dictionaries inside set, etc. So here we can store any type of data type inside these dictionaries or set or tuples or list. Okay. So now here we can use it. Let's apply this one by one. So first here we have list. So list equal underscore one. Or you can name this anything. Let's say fruits. Let's create a list of fruits. Okay. Now here we can use square brackets. Here we can name apple, can name anything. So these are known as elements. Here we can put grapes. Or here we can store any kind of value. We can store anything. We can store boolean here. We can store any type of value. Okay. Now, how we know? So how do we know that this is your list only? So here we can use print type of value we are storing inside this variable fruits. So here you can name your variable anything. It's your choice. Okay, but follow that naming conventions. That is rules of naming the variables. So here we can run this. So here you can see class is list, which is your list here. Okay, so here we can print your fruits list here. Okay, so this is your list here. Apple, oranges, grapes, these are list. Okay, so apple is a element here, oranges element, grapes is third element, etc. So one is element, second is element. So basically they are strings or numbers, but these are all known as elements inside any list, tuples, dictionary, data type, etc. Okay, so here you can see this is your list here. And this is how we can create a list. Same as here we can use here. Let's remove this. So this is list. Here we can use tuple underscore one. So here we cannot name a variable tuple because tuple is a reserved keywords, and as per the rules of variables, reserved words are not allowed. So tuple is our reserved word. So here we can use tuple underscore one. Okay. So here we can use tuple inside round brackets, that is known as parenthesis. So here we can put your variable names, or we can put anything, any sort of data type here. We can use okay. So here you can check tuple underscore one. So these are some values 1, 2, 3, 4, 5, 6. These are integers. Apples is a string, orange is string here. This is a list here, right? So here we are storing different types of data types inside your variable tuple underscore one. Okay, here we are storing a list inside tuples. So hence it is proof that here we can put any number of data types and any type of data type inside these data types, lots of data types. Okay, so print your variable name and your type of value your variables are storing. That is type. Here you can see your tuple here, and here you can see type tuple. Means it is a tuple data type. Okay. So next here we have dictionary. So here we can do dictionary underscore one. So here we can use curly braces here, and here we can name it. So basically dictionary underscore one. Dictionary is a variable, and this is my dictionary. So dictionary is like combination of key value pairs. Name is a key, John is a value. Age is a key, and 18 is a value. Same as language is a key, and Python is a value here. Okay, which is like name is a key and John is a value, which is separated by this colon here. And one key value pair is separated by a comma with different key value pairs. So here we have total three key value pairs. So first key value pair, second key value pair, and this is my third key value pair. So here we can add as many key value pair as we want. Okay. So here when you save it, Control S, and here we can run it. So here you can see this is my dictionary, and this is my classes dictionary. Means which type of data type we are storing inside any dictionary. So this is my dictionary. Okay. Same as we can we can put dictionary inside dictionaries. We can put list inside dictionary, tuple inside dictionary, etc. Okay. For example, we can put dictionary inside dictionary, which we can call nested dictionaries. Okay, nested dictionaries, which is like dictionaries inside dictionaries. For example, here, let's say dictionary underscore one equal. We can put, we will make a curly braces, and here we can start putting dictionary inside dictionary. For example, let's say letters. Okay, so this is my key here. Now value. So inside value, I'm including another dictionary. Okay, you can use your that syntax here. You can use indentation and spaces. So here we can use a, sorry. So here you can check. Here we have one key value pair. Okay, which is known as outer key value pair, which is these letters. This is my key, and inside this key, we have a value. And as a value, we have another dictionary. You can see this dictionary. Inside this inner dictionary, we have three key value pair, which is first key value pair, second key value pair, third key value pair. A is your key, one is a value here, separated by comma. B is your key, second is your value. Same as 3 is a key, C is your key, and 3 is a value here. Okay, so here we can name this like here. This one is your key here, and value this whole. That is your dictionary. Okay, so this is your outer dictionary, and this is your inner dictionary. So in this outer dictionary, we have only one key value pair, which is letters, and another dictionary. Same as here with this inner dictionary, we have three key value pairs. Okay, which is like A is your key, 1 is a value, B is the key, second is your value, C is a key, third is your value. Okay, so here we have three key value pairs. So now we can print dictionary underscore one, and here we can use print type of value your dictionary underscore one is storing. That is dictionary only. Okay, so here we have dictionary, which is you can see dictionary inside dictionary. So this is my key value pair, one key value pair, which is like outer key, outer dictionary. So first letters is my key, and this is my whole one value here. Okay, inside this value we have three more key value pairs, which is known as inner dictionary. So A is a key here, one is a value here, B is a key, second is my value, C is my key, third is my value, and here you can see class dictionary. Okay, this is how we can use dictionary. Now here we have set underscore one, which is we use curly braces for using it. Here we can put any type of data type here. Okay. For example, here we can use so this is my set underscore one. You can name your variable whatever you want. Okay. So this is my set which is inside curly braces. Apple is your value. Here is my element. Grapes is my element. Oranges is my element. 1, 2, 3, 4, 5 is my elements here. So these are known as elements of the set. Print set and type of value set is storing. So here we can see. So this is my set and class is set here. Okay. So here we have some data types. Now, so here now we will take 10 minutes break. Then after we will continue. Okay. So in the meantime, you can visit the JNtech website. So here you can search for JNtech Networks. Okay. So here we will take 10 minutes break, and in the meantime, you can visit JNtech website. Okay, you can browse it. You can browse the information, the courses. Okay. So we will continue after 10 minutes. Okay, so now we can continue. So basically we were on that set. So we will discuss that frozen set in a while. So before that, we have some data types. Okay. So here we have some categories, that is mutable and immutable. So here we can mention mutable versus immutable data types. So mutable is like here we can change it. Okay. So mutable is like we can change it. And immutable is like we cannot change it. Simple. So here we can write changeable, and immutable is like unchangeable. So it is unchangeable. We cannot change it. Okay. So basically here changes means here suppose apple is the element, orange is the element, grapes are elements. So these are elements of this list. 2, 1, 2, 2.3. This list, these are all elements of that list fruits. So so lists are mutable in nature. Means we can change it. Now change means we can replace this value. We can change value of apple with different value. We can change any value. We can change the values of these elements. Elements are like apple is an element, orange is another element, grapes is element. So basically here we can change the values of these elements. We can change values of apple. We can change or we can replace any value here. Okay, and even we can add value or we can remove value. That is important. So mutable means first we can change the values of the elements of the list. Second, here we can add or remove any number of elements. Okay, so this is mutable means we can add value, we can remove value, we can change the values of these elements inside any list. So list is mutable in nature. Now tuple. Tuples are immutable in nature. So they are immutable. Means we cannot change values. Like if we want to change value of this apple with different values, so we cannot change it inside tuple. So basically, we cannot change values, we cannot add value, we cannot replace values. Values are like these apple, oranges, these are values, as well as we can say that these are elements. So basically, here we cannot change values, we cannot add value, we cannot remove value. That is why tuples are immutable in nature. Now, dictionaries are immutable in nature. Means we can change values, we can change key values here, we can add key value pairs, we can remove any number of key values pair. That is dictionaries. Now here we have set. Set is like here. Set is both mutable and immutable. So it is both mutable and immutable. How is it possible? See, set is mutable and immutable both because so basically set is mutable because we can add value, we can remove elements. Means we can remove any number of elements. Suppose if we want to remove this apple, so we can remove it. Or if we want to add any number of elements, we can add it. So that is set is mutable in this case. But set is immutable because we cannot replace these values. Like suppose if you want to replace if you want to replace apple with some other value, so we cannot replace it. Set is immutable in nature. So hence here we can say that the set itself is mutable, but the elements of the set is immutable in nature. Okay. So apple here is an element which we cannot replace the values of this element. That is set elements of the set is immutable in nature, but set itself is mutable because here we can add any value, we can remove any value. So that is why set is like both mutable and immutable. But in case of tuples, tuples are like pure immutable, which is like we cannot add a value, we cannot remove any elements, we cannot replace any values. Okay, so that is like we can say tuple are like fully pure immutable form, and set is like both mutable and immutable. Okay, so here we have frozen set. So from this nature of set, set is like both mutable and immutable. So from this nature, here we have frozen set. Frozen set is used to make set fully immutable. Okay, so it is used to make set fully immutable, because as we know, set is like both mutable and immutable. So frozen set is like which is used for making set fully immutable. Okay, so here frozen set is like a type of constructor here. You can write frozen set and name of a set which you want to make immutable. Okay, that is this one. So we can try this. Here we have this set here. Okay, now this set is both mutable and immutable both. Right. So here we can make this set fully immutable by using frozen set. So for this we can use set underscore can you use frozen underscore one equal. So we can use a frozen set constructor here, set underscore one. Now this is immutable form, and we can print the type of value this frozen underscore one is storing. Okay, and frozen set itself, frozen underscore one means value of that frozen. So here we can run this. So this is class is frozen set. Means this class is known as frozen set. Because here we are converting your set into frozen set, which is fully immutable form. A type of value here you can see frozen set and frozen set itself. Okay. So we have these data types in Python. That is strings, which is inside quotations. Quotations can be double, single, or triple quotations. We have numbers, which is like integers, float, and complex numbers. We have Boolean values, which is like true and false. We have mutable versus immutable, which is like mutable can be changed, immutable cannot be changed. Okay, which is like here we have list, which is mutable, tuple, which is immutable in nature, dictionary mutable. We can change the values, we can add any values, we can remove any values. And set, which is like mutable and immutable both. Means we can change, we cannot like replace these values, but here we can remove these values or we can add any values, which is like elements. Frozen set is it is like fully immutable form, which is used to make your set fully immutable. Okay. So we have some kind of these data types here. Now here we have typecasting. So typecasting is like changing, or we can say converting. Okay, so typecasting is like converting your one data type into another. That is known as typecasting. Okay, so here, for example, if you want to convert your list into tuple, or if you want to convert your tuples into dictionaries, etc. So that is known as typecasting, changing your or converting your one data type to another. Okay, for example, here, suppose we have a string here. Let's say name equal Okay, you can see a number. So this is a string, as we know. Okay. So any set of characters inside double quotations are known as strings. So these are inside this number 1010 is inside quotations. That is double quotations. So this is a string here. Now here we can convert this strings into number or into integers. That is, let's say num, can say int and underscore num equal. We can use int and value you want to convert. That's num1. Okay, and it your num1 int 1 here. Okay, so now here we can check print type of value we are storing inside num1. And same as we can check type of the value we are storing inside int underscore num. Here we print num1. So basically num1 is a value here. It is a type of string here. 10 is a string. Okay, which is inside quotations. Here you can see. Now first we will print type of value num1 is storing, which is obviously a string. Second, here we are converting your string into number. Which number? Integers. Okay, so here we are converting integers. And which value we are like converting? This value, num1. And then here we are checking the type of value we are storing inside this number, which is integer only because here we are converting and printing that string like integer. So here you can check first that 10 number is a string here. Then we have converted your string into integers, and here you can see class int. The same variable is now your string, sorry, integer here, and your value here. Same as we can convert your this number or this string into float. Okay, so here we can put float underscore num equal float num. Okay, and here we can print type of value we are storing inside float underscore num. And here we can print the float here. Okay, now here we can run this. So here you can check. So to print number underscore num. So here you can check. This is a string, that is this one. This number 10 is a string here. Now here we have converted that string into float value, which is you can check the type of value of float underscore num is storing, that is float. Okay, because we are converted into float only. And here you can check the type of value we are storing and the value itself, that is 10 here, 10.0, which is your floating point numbers. So this is how we can convert your one form to another. Okay. But here you cannot convert your string like, for example, name equal John. So John is a alphabet here. Okay, like it is a combination of letters. So here we cannot convert this number, these letters into numbers. For example, in underscore num equal it and your name here. Right? Your underscore name. So this will throw an error. See, because here we are converting your letters into numbers, which is like not possible. That is why we have this error here. Okay, so here we can convert your string numbers into numbers only, just like this one. This is number in our case, but it is a string because this is inside quotations. So that is why here we are converting your number into that, your string number into that original number. Okay, that real number. So here you can see name is a, here it is a letters, or it is like a combination of alphabets, and here we cannot convert this alphabets into any number. Okay, so this is how we can convert your string into integers and float. Same as we can do with this, we can do vice versa. For example, here we have number 10. So this is my number and it is integers here. Here we can convert, let's say we can use str underscore num equal. We can call str here and which value I want to convert is num1. And here you can print the type of value your str underscore num is storing. Right. And we are printing your value itself, that is your str underscore num value. And here we are using the same print type of value. Here we are storing inside num underscore one, num1, same as the value itself. So num1 here it is a integer here. Here now we are converting that string number, that is integer, into string. And here we can run this. You can see the answer. So 10 here, previously 10 is a integer here, which is number. And here we are converting your integer into string. Now you can see the same number is a string because here we have converted it. Okay. Same as we can convert any float number, let's say 10.77 is a float number. Okay, here we can run the same. So 10.177 is a float number. And here we converted. Now this is a string. Okay. So this is how we can convert one data type to another. Same as we can do with the Boolean values. For example, bool underscore one is a true. Okay. So here we can write print type of value. Bool underscore one is storing. Same as print bool underscore one value. Okay, now here we are converting Boolean into string, which is like str underscore bool. We can name anything you want. Str, which value you want to convert bool underscore one. Okay, I want to convert this to into string. Print type of value. Str underscore bool is storing. Print str bool. Okay. So here you can check. First, previously we have true is a Boolean value here because Boolean contains true and false. So this is Boolean here. Type is class bool or your value here. It is true. But here we have converted Boolean into string. So here you can check type of value your str bool is containing, which is string. Because in this variable we have converted your your bool into string with this str keyword here. And here you can check print str underscore bool, which is true here. Okay. So this is how we can convert your Boolean into strings. Now here we have list. So let's say we have a list of some elements. Okay, any type of elements we can put. Any string. Okay, so this is my list here. When you check the type of value, your list underscore one is storing. So here you can check this is a list here, as it is inside that brackets, square brackets. And here you can check print your list here, print your list here, or value of your list underscore one. Okay, that is here you can check this one. So this is my list here. Now here we will convert this list into tuple, which is like tuple underscore one equal. We can call tuple as a constructor here. And here we can use list underscore one. Now we can print a type of value, a tuple underscore one is storing and your tuple itself. Okay. So this is the list here, type of value, your list itself here. That is inside square brackets. Here now we are converting that list into tuples. So here you can see class is now tuple, which is here we are converted that list into tuples. Class is tuple here, and you can see now that round square brackets is converted into round brackets. So this is like the difference in examining list and tuples. Tuples list uses parentheses, sorry, round square brackets, and tuple uses parentheses. Okay. Same as we can convert it into set. Okay, for example, converting list into set. Okay, for example, set underscore one. Here we can put set and which one I want to convert. Basically, I want to convert this list here. So here we can put list underscore one. Now here we can print the type of value that set underscore one is storing and then set itself. Okay, here you can check. So this is my list and this is my set. So class is set here and you can see a difference in the brackets. So this is square brackets, which is list, and this is curly braces, which is set here. Okay. Same as we can do with this tuple here. Okay, suppose here we have a tuple underscore one. Let's name this. Put any kind of value here. Okay, we can put in some boolean values, etc. So this is my tuple. Let's check the type of value. So now here you can check. This is my tuple. And here we are checking the type of value tuple underscore one is storing, which is tuple only, right? Here you can see class tuple and this is a tuple here. Now we can convert this tuple into list. So here we can put converting tuple into list. So here we can use list underscore one as a variable name equal your square brackets, and here we can put list and value name, and here we are printing type of value we are storing inside list underscore one. So, and print your tuple itself. Okay. So here you can check. So this is my tuple here. And now here we are converting a tuple into list, which is like a list. Here we can pick the list underscore one itself. So here you can see the difference. First is class tuple, and here now this is list. This is now converted into list. Okay, same as we can try with the set as well. So here we can write converting tuple into set, which is like we can put set underscore one, and here we can use set as a constructor here, and we can put which data type I want to convert. So in this case, I want to convert tuple underscore one, and here we can check the type of value that set underscore one is storing, and here we are using set underscore one itself. Here we can use it. You can see tuple, and now it is converted into set. And here you can see that round brackets converted into that curly braces. So these parentheses has been converted into curly braces. Okay, so this is how we can convert your one data type from another. And last we can try with set. So here we have set underscore one. Equal. Let's say, let's put any number, any elements, number of elements here. So here we can put it type of value that set underscore one is storing with set itself. So here you can check set here. So this is the set, and here we are printing that set here. Same as we can convert set into list and tuples. Okay, for that we can use list underscore one. Here we can use list which element or which data type I want to convert, that is set underscore one, and here we can print type of value we are storing inside list underscore one with this list itself. Okay, so here we can run this. You can see first it is set. Now here we have converted your set into tuples, the same set. Okay, now here you can see the list. Same as we can try with tuples here. So here we can remove this. So tuple underscore one equal tuple and that set which you want to convert your variable name here. Print type of value we are using with converting tuple underscore one. Here you can see print for tuple itself. So here you can see. So this is the set. Okay, and now here we have converted that set into tuples. So this is how we can use set. Like this is how we can convert your one data type to another. Okay. Now here we have some more ways of like creating your data types. So here we can write another way of creating a data types. Data types like list, tuples, dictionary, set. Okay. So here basically this is how we can create a list inside square brackets, right? Can put any number of elements here. So this is how we are creating a list. Now, there's one more way of creating the same list with using list constructor here. That is list underscore second. Here we can use list as a constructor here, and we can use double parentheses. Okay, and here we have to name some elements, whatever you want to put inside your list. So here we can put any numbers, anything we can put. Okay, you can put any number of elements, you can put any type of data types. Okay. So this is one way, this is second way. Both are list. If you want to print this list type of, if you want to check your type of value, your list underscore second is storing with this itself. So here you can see. So here we are checking for list underscore two. That is your class is list, because here we are using list as a constructor here with these round brackets. And here you can check the type of value we are storing inside list underscore two, which is your variable name, that is list, and your list itself, that is inside. Here you can notice it is inside square brackets because it is a list here. Okay, the same list we have created here, which is represented here. Okay, so this is one way, and this is another way. So you can use any of these ways. So it depends on your choice. Okay, so this is first way and this is second way. Same as we can try with tuples. So here we can use tuple underscore one, which is your tuple here. We can put anything. Sorry. We can put any number of elements here. So this is first way, or this is one way. Now the second way is tuple underscore second. So here we are using tuple as a constructor here, and name of your elements here. Use your round brackets and name of your elements. Okay, or your elements here. So here we can put any elements. Like here we can put name of anything, name of languages. We can put anything we want. Okay, and same as here we can check the type of value. Your tuple underscore second is storing, and your tuple itself. That is a value of a tuple. Okay, and this is the second way, or we can say another way. Here we can run this. So you can see tuple underscore second. Sorry, here it would be type of value. So here you can see tuple, and this is the second way, and here this is the tuple only, which is inside your round brackets. So here we can put any number of data types and any type of data types. Okay, so both are same. So this is your one way or your first way, and this is the second way. So you can create your list, your tuples either way. Okay, same as we can try with dictionaries. Now the syntax of dictionaries are different. So here in dictionary underscore one. So basically here we create using curly braces with key value pairs. Name, your value here, comma, your second key, your value here, and your third key, your value here. Okay. So here we can, so this is my one way. So my second way is we can use dictionary underscore second, dictionary as a variable name. Okay. So this is your variable name, dictionary underscore two, and this is a constructor here. And here we can name your values. So A equal 1, B equal second, C equal 3, D equal 4. Okay. So you can like put any number of key value here. So A is a key here, 1 is a value. Okay, which is separated by equal sign. And this is one key value pair, this is second key value pair. Okay, and this is third key value pair, C, D, fourth key value of E, fifth key value pair, which is all separated by comma. So this is one way of creating a dictionary. This is second way. And here we can print your dictionary, type of dictionary underscore two. And here we can put print dictionary underscore second. And here we can run this. You can see. So this is your dictionary, type dictionary here. And here is the value. A is your key here, which is here we have put. A is key, one is the value, which is separated by comma here. Okay. So this is a one way, or this is a second way. So you can get your dictionary of like either way. You can create with this way or with this way. Both are same, or both are correct. Last we have set and underscore one. So one way of creating set is using curly braces. Okay, which is like here we can put any number of values. We can put any number of elements here. Second, so this is my one way inside curly braces. Now, second way is you can use set as a constructor here. So this is my one way, and this is my second way. Okay, which is the set here. So here we are using set as a constructor here, and your set here. Okay, and this is the type of value you are storing, and your set. Here we can connect. So basically here we have to use double parenthesis. One more parenthesis here. Okay, now we can run it. So you can see class set and these data types are inside. These elements are inside curly braces. Okay, so this is your one way of creating your set, and this is a second way. Both are same. You can create either way. Now here we can convert your any type of data type into frozen set. Means here we can convert list tuples. We can convert set into frozen set, which is like here. Let's say here we have a list. So let's copy the list from here. So this is my list. Now here's my print, the type of value, the list underscore one is storing with a list here. Now here we are converting that list into frozen set. That is here we can use frozen underscore list. So frozen set and your list here you want to convert. That is list underscore one. And print the type of value here we are storing. That is frozen set. And frozen underscore list and your value. So here you can check. This is my list. And this is how I'm converting my list into frozen set. Which is like list is mutable in nature and frozen set is like immutable in nature. So here I'm converting my list nature, which is mutable, into frozen set, which is immutable. So here you can check this is my list. And here I'm converting my list into frozen set, which is here you can see frozen set here. Okay, the same list is in frozen set. The same I can try with tuples here. So let's copy tuples from here. Control C. Here we can check type of value that tuple underscore what is it storing with your tuple underscore value. Okay, same as here, we're converting your tuple into frozen set. So here we can write frozen underscore tuple equal, call your frozen set constructor here. Now which value or which tuple or which data type we want to convert into frozen set. So here we can check Okay, so this is your tuple and this is how we are converting. So let's run it. So here you can check. So this is my tuple, and this is my frozen set, which is converted into like frozen set. Okay, same as we can try with set. Okay, so that is set underscore one equal your set here. Okay, so here we can copy any elements from set. We can check the type of value that set underscore one is storing with this set underscore one. And here we are converting your set into frozen set. So here we can put frozen underscore set or frozen underscore one. Call your frozen set here set underscore one. Okay, now here we can run it. So here you can see, here we have set. Now here we are converting your set into frozen set. And here you can see we have a frozen set here. So this is how we can like convert your one form of data type into another. Same as this is how we can like create your one data type. Okay, here we can create list and here we can create with list constructor here. Okay, and set or tuple or dictionary constructor. So there are two ways of creating any data type. Okay, now next here we have input function. So input function is used to take input from the users. For example, here there's one more point. Input function takes input always in the form of strings. That's like the nature of an input function. So input always take input in the form of that strings. Okay. So here, how we can use input? So basically here we have to use input as a function name. For example, if you're asking for the name from any user, name equal, here we can put input. Now here we have to put enter your name or whatever you want to print name. Okay, and here we can print name of that user. Okay, so we can try here. So name equal input. Here we can put enter your name. Okay, same as input print name itself here. So name is a variable here and input is a function here, which is like used to take input from the user. And input always take input in the form of string. So if you put it, you run it. So don't run from here, run from your terminal here. Click on here, terminal here, click on new. Okay, so here click type Python, name of your file, that is hello.py in my case. Name, let's say John. So here you can see John has been printed. So this is how we can use. And if you check the type of data type, we are like printing, print type of data type here. Okay, so here you can. Okay, so give me a second, guys. So here you can check age equal input, enter your age. So here we are taking age as an input here. So we can check the type of value age is storing, which is in, string here, because whatever the input will take as a, so whatever the like variable that use whatever that string, whatever that variable will take as an input, that is string only. Okay, so here we can put the type of value that is of age. So here we can use Python name of your file, that is hello.py in my case. Your name, that is John, age, let's say 18. So here you can see John is basically a string. 18 is a value here for us, it is a number, but input will take always as a string here. That is why 18 is also a string. Okay. So let's take another example. So here number one, input, enter your first number and second number. Okay, so here now we will perform a addition here. That is, so number plus num second. So here we can run it. So here name of your Python and name of your file, that is hello.py. Okay, so number one we can put 11, 11. So now you can see instead of adding, so it is showing, it is like concatenating. That is like 11, 11 together, right? So basically here we are adding two strings together. That is 11 plus 11, like this. Which is like, these are strings here, 11 and 11. So that is why 1, 1, 1, 1. These are like concatenation. So input will always take your input or user input in form of strings. So now we have to convert your string into numbers, right? So what we can do, we can put int here. So int here, input your number, your second number. So now here we are converting that strings into integers. So now if we run it, you can see the result from here. That is Python. Name of your file, that is hello.py in my case. Number 10, 11. Now you can see 21. Or if you want to run this again, you can run it 13. So now here we are adding it because this string, this input will always take strings, like input in the form of strings. Now, so here now we're converting your string into numbers, that is integers. Okay. So this is like adding two strings together is known as concatenation. And 11 plus 11, these are integers, or you can add float, any numbers. This is known as addition. And both are performed by this plus operator here. Okay, so the difference is here we are adding strings and here we are adding numbers. Okay, so now let's take another example. So here we are taking three numbers, number, num2, num3. Okay, first, second, third number. And here we are storing these numbers, like total of these numbers inside one variable. And here we are printing that variable. Okay, so now run this. And here you can see we are converting this number like string into integers. We can convert it into float as well. So here you can put integers or here you can put float. Okay. So here we will convert into integers here first. Okay. So now clear the screen. Here we can put Python name of your file, that is hello.py. First number, and here you can notice this number. Enter the first number. So this is like in this colon and space. So this is like as it is printed here. This is space including colon here. So make sure whatever you are printing inside this quotation, that will be visible by the users. Okay. So whatever you want to input, whatever questions you want to answer, like put for the users, you can put inside that quotations. So here you can see number 10, 13, 32. And here you can see the total of these numbers. Okay. So either you can put these numbers inside a variable and you can like print these variables, or you can put it directly. Number one plus number second plus number three. We can remove this line, these two lines. Here you can see. So here you can see. Sorry. That is three. Okay. So let's take the last example for that. Now we will convert your strings into float with input. Okay, that is so number one, your first number, second number. Okay, now here we can print number one plus number two. Now you will see the answer is in float because here we are converting your string into float here. So here we can run it. You can clear the screen. You can press upper key. Here you can see first number, let's say 12. Any number. Here you can see number is in float numbers. That is like decimal numbers. So this is how we can use input in any form. So if you want to perform any mathematical operations with this input, so you can convert that into float or integer. That depends on your requirements. Or if you want to like display anything, you can simply use input. Okay. So now here we have comments. So comments are like here we can put so here we can write comments are ignored by the interpreter of the Python. And these are specifically for the note taking. Okay, so suppose, and here we have types of comments, which is like here we have single line comments, Second, we have multiple line comments. Okay. So single line is like here we can put hash, and this is my comment or whatever you want to put. Second, we have multi-line comments. It is like here we have to use triple quotations. That is this one. So this is my comments. Okay, so here we can use it. So basically, why do we use comments? Suppose you want to take any notes in the Python code. Okay, then you can put, for example, suppose print hello world. So print is a function which is used to print something, right? So suppose you want to write this definition here. That is print is a function which is used to print something. So here we cannot put anything like in the Python code. We cannot put anything because is here is a this is a word print is a function here. This print is a function here. So here we cannot put anything here. So here that is why we use comments here. So when you put a hash here, that is this one. Now this becomes a comment, and this line will ignore by your Python interpreter. Okay. So when you run this, we don't have any error. Okay, and when you remove this hash, this is a line which is like a error line because it is like a combination of some reserved words. Okay, that is invalid syntax. So that is why here we use comments. So this is a single line comments, and here we have multi-line comments. That is this one. So here we can write this is my comment, or if you want to use some more lines, you can use it. So that is a comment. So basically, you can write anything. You can write whatever you want. You want to take note, or you want to write some point here. So you can put using comments, because comments are like basically is ignored by your Python interpreter. So here you can see, and here we have a shortcut of commenting. For example, this one. Inside VS Code, you can select this line, and you can press Control/. This one for comment and for uncomment both. Okay, so here's a shortcut for commenting or for uncomment. So for comment, here you can put Control+/. Same as for uncomment, you can use the same shortcut. That is Control+/. Okay, same as here we can use. You can like select it, Control+/, and forward/ same button here. Okay, so for commenting or for uncommenting, you can use it. So now last here we have indentations. So indentations are like the spaces which is required before any line. Okay, so here we can say spaces. Inside, we can say inside functions, we can say and conditions or loops, etc. We can use inside functions. We can use inside classes or objects, basically classes. We can use inside conditionals, which is like your if-else statements, loops, etc. Indentations are like a specific space. For example, here, let's write a function here, def un. Don't worry about this function, we will discuss soon. Okay. So this is my function. def function. Okay, now here you can see a space. This space is known as indentation. Okay, that is this little space. And this space is known as indentation. Okay, basically in the C, C++, we uses parentheses or brackets for in place of this spaces. But Python is a very easy language. That is why we use spaces in place of these complex parentheses or brackets. Okay, so space is very mandatory here. Suppose if I remove this here, then here you can see there's a red line here, which is like an error line. So this will give you an indentation error, which is like indentation is important here. Okay, so that is the when type space is important. So here we can use indentation at various places. We can use inside functions, inside if else statements, inside loops, inside classes, etc. So these indentations are very important. Okay, or here we can put any if condition if. So here you can see this indentation is important. Okay, and this space is known as indentation. Okay. So that's it for today. So rest we will continue tomorrow. Okay. So if you want to visit the JNtech website, if you want to check out the course content of core Python and advanced Python, then you can visit the JNtech website. That is JNtech Networks. Here you can click on this URL. So here you can click on Python. And here you can scroll down. And here you can find the modules of Python core and advanced. Okay, and you can check out the fee structure, the course duration, etc. And if you have any doubt, you can call on this number or you can mail. Okay, or you can WhatsApp from here.